Hello there, and welcome to AR Calm Science. Tonight, we're drifting into one of the strangest and most intimate territories the mind ever visits: dreams. Every night, without asking permission, your brain builds entire worlds, populates them with faces you sometimes recognize and sometimes invent, and hands you experiences so vivid you sometimes cannot tell in the moment that none of it is real. This has been happening to every human who has ever lived, every single night for as long as our species has existed, and yet dreams remain one of the least understood things happening inside your own skull. Tonight, we will explore what dreams are made of, why they happen, what your brain might be doing while you sleep through them, and why waking from a dream can feel like stepping out of a life you were fully living just seconds before. We will look at memory, emotion, biology, and the strange architecture of a mind left alone in the dark. If you enjoy these gentle journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here too, one sleepy soul at a time. But for now, all you need to do is settle in. Let your shoulders soften, let your breathing slow, and allow your mind to rest into stillness as we explore the hidden science of dreams together. Let's begin. Your brain is more active during certain dream stages than it is during many waking moments. It seems intuitive to imagine sleep as a quiet, low-power state for the brain, a dimming down after a long day. But during REM sleep, the stage most associated with vivid dreaming, brain activity can resemble, and in some measurements even exceed, the activity seen during wakefulness. Neurons fire rapidly. Regions associated with vision, emotion, and memory light up in complex patterns, and the overall electrical signature of the brain looks remarkably similar to being awake, despite the body remaining still and the eyes closed. This is part of why dreams can feel so immersive. The brain is not idling through them. It is working, constructing, and experiencing at a level of intensity that rivals anything you do. Your eyes open. Your body is temporarily paralyzed during REM sleep, so you cannot act out your dreams. While your brain races through vivid dream scenarios, your muscles, for the most part, do not follow along. A mechanism in the brainstem releases chemicals that effectively switch off voluntary muscle movement during REM sleep, a state called REM atonia. This is why you can dream of running, flying, or fighting without your legs actually kicking or your arms actually swinging. It is a remarkable safety feature, evolved seemingly to prevent the body from physically responding to imaginary events. In rare cases, this mechanism fails, a condition called REM sleep behavior disorder, where people do physically act out their dreams, sometimes with startling intensity. The existence of this disorder highlights just how deliberate and necessary the paralysis usually is. A quiet, nightly safeguard most people never notice is even there. Nearly everyone dreams every single night, even those who insist they never do. Sleep researchers have found, through laboratory studies involving repeated awakenings during REM cycles, that virtually all humans experience dreams multiple times per night, typically 4 to 6 times, regardless of whether they later remember any of it. People who claim they never dream are, in nearly all cases, simply not retaining the memory of dreaming, rather than skipping the experience altogether. Dream recall depends heavily on when you wake up relative to a REM cycle, how abruptly you wake, and even certain personality and sleep pattern differences between individuals. So the sense that I don't dream is almost always a memory gap rather than an absence of the experience. Somewhere behind that quiet forgetting, an entire night's worth of imagined life has usually already come and gone.
Dream recall fades unusually fast, often within minutes of waking. Dreams have a strange relationship with memory, vivid and complete in the moment, then dissolving almost as quickly as they arrived. Studies suggest that without deliberate effort, most people forget the majority of a dream within just a few minutes of waking, and nearly all of it within the first 10 to 20 minutes. This rapid fading may be linked to the same neurochemical state that allows dreaming to happen in the first place. Certain memory consolidation chemicals are reduced during REM sleep, making it harder for the brain to properly file dream content away the way it does with waking memories. This is why dream journals, kept at the bedside, work so well for people wanting to remember more. The trick is not effort of memory, but speed, capturing the dream before that narrow window closes.
The strange, illogical qualities of dreams may come from parts of the brain temporarily working differently than they do while awake. Dreams often feel bizarre, not because your brain is broken, but because certain regions responsible for logic, time tracking, and self-monitoring show reduced activity during REM sleep, particularly areas in the prefrontal cortex. Meanwhile, regions tied to emotion, imagery, and sensory experience remain highly active. This imbalance may explain why dream logic feels so different from waking logic, why a dream can shift settings instantly without confusion, why impossible things can feel completely normal in the moment, why a dead relative can appear and feel entirely unremarkable until you wake up and question it. The brain is not failing at logic during a dream. It has simply, temporarily, turned down the very systems that would normally flag these things as strange. Some of the most vivid emotions you will ever feel may occur entirely within a dream. Dream emotions are not faint echoes of real feeling. They are frequently full intensity experiences, indistinguishable in the moment from anything felt while awake. Fear in a nightmare can trigger real physiological responses: racing heart, sweating, a jolt of adrenaline, even though nothing in the room has actually changed. Joy in a happy dream can feel every bit as complete as joy experienced in waking life. This happens because the brain's emotional centers, particularly the amygdala, remain highly active during REM sleep, generating genuine emotional responses to imagined events. Your body does not necessarily distinguish between a threat that is real and a threat that is only dreamed, which is part of why nightmares can leave you shaken even minutes after waking. The fear itself was never fake, only its cause. Nightmares may serve a protective, rehearsal-like function, rather than simply being unpleasant accidents. One theory in dream science, sometimes called the threat simulation theory, suggests that nightmares may function as a kind of practice space, allowing the brain to rehearse responses to danger, conflict, or fear in a low-stakes environment before facing anything similar while awake. Under this theory, dreaming about being chased, falling, or confronting a threatening figure may not be random misfires, but evolutionarily useful simulations, letting the brain refine emotional and behavioral responses without any real risk involved. This reframes nightmares slightly, less as something gone wrong and more as an ancient training ground the mind still visits nightly, quietly preparing itself for situations it may never actually encounter.
but treating the rehearsal seriously all the same. Dreams often recycle emotional residue from your waking life, especially unresolved feelings. Many dream researchers have found that dream content is frequently connected, sometimes obviously and sometimes obscurely, to emotional experiences from recent waking hours. This does not always mean a dream directly replays an event. More often, it borrows the emotional tone, anxiety, longing, frustration, and builds an entirely different scenario around that same feeling. A stressful, unresolved conversation from the day might resurface as a dream about being lost, not because the settings match, but because the underlying emotional signature does. This suggests dreams may function partly as an emotional processing system, sorting through feelings that were not fully resolved during waking hours and giving them a strange, symbolic stage to continue playing out on. The brain may use dreams to strengthen and reorganize memories from the day. Sleep, and REM sleep in particular, appears to play an important role in memory consolidation, the process by which short-term memories are stabilized into longer-term storage. Some researchers believe dreaming itself may be a visible side effect of this deeper reorganizing process, the brain sorting through recent experiences, strengthening some connections, weakening others, and occasionally producing strange narrative fragments as a byproduct of that filing work. This would mean dreams are not simply entertainment or noise, but a kind of visible echo of your brain quietly managing its own archives overnight, threading fragments of yesterday into images and stories that may never make literal sense, but still reflect real underlying cognitive work. Some people can become aware they are dreaming while still inside the dream, a state called lucid dreaming. Lucid dreaming occurs when a dreamer becomes conscious of the fact that they are dreaming, sometimes gaining a surprising degree of control over the dream's events as a result. This state has been studied extensively, using specific eye movement signals dreamers can make during REM sleep, since the body remains paralyzed, but the eyes can still move, allowing researchers to confirm in real time that a person is lucid and dreaming simultaneously. Brain imaging during lucid dreams shows a distinctive pattern: increased activity in areas associated with self-awareness compared with ordinary dreaming, almost as though the logical, monitoring parts of the brain that usually quiet down during REM have partially switched back on, allowing the dreamer to realize mid-adventure that none of it is quite real. Certain techniques appear to increase the likelihood of experiencing a lucid dream. Some methods used by dream researchers and hobbyists alike include reality testing, repeatedly checking throughout the day whether you are dreaming, which can eventually carry over into the dream state itself, as well as keeping detailed dream journals to strengthen dream recall and pattern recognition. Another common method involves waking briefly after several hours of sleep, staying awake just long enough to become alert, then returning to sleep with the specific intention of noticing the dream state. While lucid dreaming is not something everyone experiences naturally or easily, these practices have shown measurable success rates in laboratory settings, offering a fascinating glimpse into how much conscious intention can influence what happens even after the waking mind has, in most other ways, gone quiet. Dreams may play a role in creative problem solving, sometimes offering solutions the waking mind could not reach. There are numerous documented cases throughout history of people crediting dreams with helping solve complex problems, from scientific breakthroughs to artistic inspiration. The chemist August Kekulé famously described realizing the ring structure of benzene after dreaming of a snake biting its own tail. While such anecdotes cannot be treated as rigorous proof of mechanism, they align with what researchers now understand about REM sleep's role in loosely connecting distant pieces of information, allowing associations that the more structured, logical waking brain might overlook. Dreaming, in this sense, may offer a freer associative space, one where ideas can combine in ways rigid daytime thinking would never permit, occasionally producing insight that feels less like memory and more like discovery.
The imagery in dreams may draw more heavily on emotion and memory fragments than on literal storytelling logic. Unlike a scripted narrative, dreams tend to be constructed from loosely connected fragments, a place from childhood, a stranger with a familiar voice, an object that shifts identity halfway through the scene. Researchers studying dream content suggest this reflects how the sleeping brain assembles experience, pulling from stored memories and emotional associations rather than composing a deliberate plot. This is part of why dreams so often defy straightforward interpretation. They are less like stories with intended meaning and more like a collage built loosely and quickly from whatever material happened to be most emotionally or neurologically active at the time, arranged in patterns that feel meaningful in the moment, even when their logic resists translation afterward. Sensory input from the real world can sometimes weave itself directly into an ongoing dream. Sleep researchers have observed that external stimuli, a ringing phone, a dripping faucet, a change in room temperature, can be incorporated into dream content in real time, often reshaped to fit whatever narrative the dream was already building. A sound might become a phone ringing within the dream itself, or cold air might translate into a dream about standing outside in winter. This phenomenon suggests the sleeping brain does not fully disconnect from sensory input, but instead continues processing it, weaving real signals into the dream's ongoing fictional structure almost seamlessly, blurring the boundary between what is actually happening around your sleeping body and what your mind is simultaneously constructing around it. Falling dreams are among the most universally reported dream experiences across cultures and history. The sensation of falling in a dream, often accompanied by a sudden jolt awake, appears across countless cultures and historical periods, suggesting it may tap into something deeply rooted in human physiology, rather than being shaped primarily by culture or personal experience. One theory ties this to a phenomenon called a hypnic jerk, a sudden muscle contraction that can occur as the body transitions into sleep, possibly triggered by the brain misinterpreting muscle relaxation as an actual physical fall. Whatever the precise mechanism, falling dreams remain one of the most consistently reported dream types worldwide, suggesting a shared thread of nervous system experience running beneath the wide diversity of human dream content, otherwise shaped by culture, memory, and individual life. Flying dreams may be linked to feelings of freedom, control, or the mind's response to certain physical sensations during sleep. Dreams of flying, gliding, or floating are reported frequently across many populations and are often described as some of the most pleasant dream experiences people have. Some researchers link this to vestibular system activity during sleep, the balance and spatial orientation system that can behave unusually while lying still for extended periods, potentially producing sensations the dreaming mind translates into flight or floating. Others point to psychological interpretations, suggesting flying dreams may correlate with feelings of empowerment, freedom, or release from constraint in waking life. Whether rooted primarily in physiology or emotion, or some blend of both,
This particular dream theme appears frequently enough across dream research to be considered one of the more universally recognizable categories of dream experience.
The brain appears to briefly heighten sensitivity to threat-related imagery during certain dream stages. Some researchers have proposed that dreaming, particularly during REM sleep, may involve a slightly heightened tendency to generate threat-related content compared with waking imagination, part of what supports the threat simulation theory discussed earlier. This would mean the brain is not randomly unlucky in producing so many anxiety dreams, but is instead following an old evolutionary pattern, using sleep as a space to rehearse vigilance and danger response, even in a completely safe sleeping body. This tendency does not mean every dream must be frightening, most are not, but it may help explain why anxiety dreams and mild nightmares are so common across nearly all people, regardless of how safe or calm their waking life actually is. Dream content often reflects the specific culture and era a person lives in, despite universal underlying biology. While the biological machinery producing dreams appears consistent across humanity, the actual content of dreams, the settings, symbols, and social situations, tends to reflect the dreamer's cultural context and personal experience. Someone living in a modern city might dream of traffic, phones, or crowded rooms, while someone from a very different cultural or historical background might dream of entirely different settings and concerns. This distinction matters because it shows dreaming operates on two layers at once: a shared, ancient biological process running underneath, and a highly individual, culturally shaped surface layer built from whatever material a particular life happens to supply the sleeping brain with each night. The brain appears to briefly heighten sensitivity to threat-related imagery during certain dream stages. Some researchers have proposed that dreaming, particularly during REM sleep, may involve a slightly heightened tendency to generate threat-related content compared with waking imagination, part of what supports the threat simulation theory discussed earlier. This would mean the brain is not randomly unlucky in producing so many anxiety dreams, but is instead following an old evolutionary pattern, using sleep as a space to rehearse vigilance and danger response, even in a completely safe sleeping body. This tendency does not mean every dream must be frightening, most are not, but it may help explain why anxiety dreams and mild nightmares are so common across nearly all people, regardless of how safe or calm their waking life actually is. Certain foods and substances can influence dream vividness and recall, though the science remains complex. Anecdotal reports connecting certain foods, particularly those eaten close to bedtime, with more vivid or unusual dreams have circulated for a long time, and some research has explored possible mechanisms, including effects on sleep architecture, body temperature regulation, and digestive discomfort that may fragment sleep and increase the likelihood of remembering dreams from lighter sleep stages. Certain medications and substances are more clearly linked to changes in dream intensity or recall, since they directly affect neurotransmitter systems involved in REM sleep regulation. While the full picture remains an active area of research, it is well established that what happens in the body in the hours before sleep can meaningfully shape what unfolds once dreaming begins. Recurring dreams may reflect unresolved themes the mind returns to again and again. Many people report having the same dream, or dreams with a strikingly similar theme, recurring over months, years, or even decades. Researchers studying recurring dreams often find they cluster around persistent life themes, unresolved anxieties, recurring life patterns, or emotional situations that have not been fully processed or resolved in waking life. Rather than being random repetition, recurring dreams may represent the mind circling back to something it perceives as still unfinished, a kind of quiet insistence that continues showing up night after night until whatever underlying tension the dream represents finally shifts or resolves in the dreamer's actual waking circumstances. Dreams involving deceased loved ones are extremely common and often carry a distinct emotional quality. Many people report dreaming of relatives or friends who have died, sometimes years after their passing, often describing these dreams as feeling unusually vivid, coherent, or emotionally significant compared with typical dream content. Some researchers who study grief and dreaming suggest these dreams may reflect the ongoing emotional processing of loss, offering the dreamer a kind of continued connection or closure that waking life does not provide. Whatever their precise underlying mechanism, dreams involving deceased loved ones are reported across nearly every culture studied, often described using strikingly similar language: peaceful, real, comforting, suggesting something meaningful and consistent in how the sleeping mind revisits the people it has lost. Sleep paralysis is a distinct phenomenon where the mind wakes before the body's REM paralysis has fully ended. Sleep paralysis occurs when a person regains conscious awareness while the muscle paralysis of REM sleep is still active, resulting in a temporary inability to move or speak, sometimes accompanied by vivid, often frightening hallucinations. This experience, though unsettling, is a known and well-documented transitional glitch between sleep stages, rather than a dangerous medical event in most cases. Reports of sleep paralysis appear across many cultures throughout history, often described using supernatural language, a sense of a presence in the room, pressure on the chest, shadowy figures, likely because the combination of paralysis and vivid hallucination naturally produces experiences that feel far stranger and more otherworldly than ordinary dreaming ever does. Children tend to have different dream content than adults, often simpler and more literal. Studies comparing dream reports across age groups have found that young children's dreams tend to be shorter, simpler, and often more literal, frequently involving animals, family members, or straightforward fears, compared with the more complex, layered, and emotionally intricate dreams typically reported by adults. This likely reflects ongoing brain development, since the regions responsible for complex narrative construction and abstract thought continue maturing well into adolescence. As children grow, their dreams tend to gain increasing complexity, layering, and emotional nuance, mirroring the same cognitive development taking shape during their waking hours, a quiet parallel track running through childhood, one built from imagined nights rather than lived days. The content of dreams may shift measurably across a single night as sleep cycles progress. A full night's sleep moves through multiple cycles of light sleep, deep sleep, and REM sleep, and dream content tends to shift accordingly. Dreams occurring earlier in the night, during shorter REM periods, are often described as more mundane, closer to replaying ordinary daily events. Dreams occurring later in the night, during longer REM periods that expand as sleep continues, tend to become more elaborate, emotional, and bizarre. This means the last dream you remember before waking in the morning is often the most vivid and complex of the entire night, not because it holds special meaning, but simply because it occurred during the longest, most active REM stretch your sleep cycle reached before morning arrived. Some animals appear to dream as well, based on observable brain activity during their sleep.
Researchers studying sleep in other species, particularly mammals like cats, dogs, and rodents, have observed brain activity patterns during REM-equivalent sleep stages that closely resemble those seen in dreaming humans. In some studies, rats have shown neural firing patterns during sleep that mirror patterns recorded while they were awake, navigating a maze, suggesting they may be replaying, or perhaps dreaming, aspects of the maze experience. While we obviously cannot ask an animal to describe its dream, this kind of neurological evidence suggests dreaming, or something closely resembling it, may not be uniquely human, but rather an ancient feature of mammalian brains, quietly present across an enormous range of species, sharing the same basic evolutionary sleep architecture.
The prefrontal cortex, responsible for much of your rational decision-making, becomes notably less active during dreaming. This particular brain region governs planning, judgment, self-monitoring, and logical evaluation while you are awake. During REM sleep, activity in the prefrontal cortex drops significantly compared with waking levels, while emotional and sensory regions remain highly active. This imbalance may explain much of what makes dreams feel so strange upon reflection. Without the usual moderating influence of rational evaluation, the dreaming brain can accept bizarre scenarios without question, shift settings instantly, and blend impossible details together seamlessly, all while feeling completely natural in the moment. Dream researchers have identified common universal symbols that appear across widely different cultures and individuals. While dream interpretation as a precise science remains controversial, certain broad dream themes appear with notable consistency across different populations worldwide: being chased, losing teeth, appearing in public inadequately dressed, taking an exam unprepared. Rather than reflecting some mystical shared symbolism,